Good morning. My name is Matt Funk, and I am a product engineer with the Defense Services Department here in Redlands, California. Joining me today is Lorraine Funkhauser, who is also a product engineer with Defense Services in Redlands. We want to welcome you all to today's live training seminar, Introduction to ArcGIS Military Analyst 9.2. Today we'll start off with an overview of Military Analyst, what it is, what it can do for you, and where you can get it. Then I'm going to group Military Analyst's functionality into 3 sections and go into more detail on each. We'll cover coordinate conversion and geodetic measurement, data management with Military Analyst catalogs, and we'll wrap up with a brief coverage of terrain analysis capabilities. Each section will be followed with a demonstration of the functionality, and we'll conclude with a question and answer session from Lorraine. So let's jump into an overview of ArcGIS Military Analyst. So what is Military Analyst? Military Analyst, or MA, is an extension to ArcGIS Desktop, ArcEngine, ArcReader, and ArcIMS product lines, and was designed for users in the defense and intelligence communities. Its capabilities include collecting, managing, and displaying NGA standard data sets, specifically digital terrain elevation data, raster product format, and vector product format through the use of Military Analyst catalogs. Military Analyst also has the ability to do some basic terrain analysis on elevation data sets and catalogs. Analysis such as line of sight, highest and lowest points, and hill shading are made easier in Military Analyst by combining workflows from Spatial Analyst and 3D Analyst into a single tool. Coordinate conversion is another function at the core of defense and intelligence work. Common coordinate formats such as decimal degrees, degrees, minutes, seconds, universal transverse Mercator, or military grid reference system may be received from various sources and converted to your organization's standard format. Military Analyst also has tools to do geodetic measurement. For example, if I have a DTED catalog and I want to know the geodetically correct distance and direction between 2 points, I can use the Geodesy graphic tool to draw a line across my map display, starting and ending on those points, and it will tell me the geodetically correct distance of 82 kilometers and 123.1 degrees. Other applications of Military Analyst include collecting your existing DTED, RPF, and VPF data sets into a single centralized basemap repository for use by intelligence analysts in remote offices, or looking for the best cross-country travel routes by comparing aircraft refueling ranges from existing air bases. You can even do basic cross-country mobility modeling to determine the best route for observation. So where can you get Military Analyst? Well, the very first thing you should know is that Military Analyst is a free extension. Yes, you've heard that correctly. It's a free extension. As long as you have installed one of the parent products that Military Analyst extends, you can download and use Military Analyst almost immediately. For some of the terrain analysis tools, you must have a Spatial Analyst or 3D Analyst license installed, but we'll cover the specifics of that in our final section today. You can download Military Analyst from the ESRI website, or you can contact your local ESRI account manager or international distributor for a CD that includes Military Analyst and its companion product, Military Overlay Editor. Now that we've gone through a brief overview of Military Analyst, let's take a closer look at its coordinate conversion and geodetic measurement capabilities. Coordinate conversion is handled through the coordinate tool, which exists as a dockable window in ArcMap. It's designed to convert coordinate values between military grid reference system, universal transverse Mercator, degrees, minutes, seconds, and decimal degrees. A few examples of these coordinate types are listed to the right. The coordinate tool also features options to add a graphic point in your ArcMap display to identify the coordinate location. If you're zoomed into a particular scale, there's another option to center in on the location during the conversion as well. This offers the user a quick way of finding a location if all you have is a set of coordinates. The coordinate tool is also used as an input device for many of our other tools, including the terrain analysis tools, which we'll discuss later. If you have a table or point feature class with coordinate values, you can do a batch coordinate conversion with the Convert Coordinates in File tool. This tool will convert between military grid reference, UTM, degrees, minutes, seconds, and decimal degrees, and will append new fields to your input data set, or it will create a new data set with the coordinate fields added. Convert Coordinates in File will also accept variations in different coordinate formats. The list of coordinates in the third bullet point shows the same coordinate with different hemisphere indicators and different coordinate delimiters. A complete list of the format variations accepted is found under the Military Analyst's Coordinate Conversion section in the ArcGIS online help system. Beyond basic coordinate conversion, Military Analyst has the ability to do basic geodetic measurement. Geodesy is the study of the measurements on the surface of the Earth. We've all learned that taking a spherical map of the Earth and flattening it out using projection formulas will introduce errors and distortions into that map. So we use geodetic calculations to account for those distortions. For example, if I have a blue geodesy line going from Alaska to Brazil, and they followed up with a straight two-point polyline in red, we can see that the locations both follow along their path. They start out in Alaska, go through the Pacific Ocean, through the western U.S., through the Caribbean, and end up on the eastern tip of Brazil. But as I change coordinate systems, you'll notice that the blue geodesy line pretty much follows the same path, but the red polyline has moved much farther north. Military Analyst has three geodesy tools for analysis and measurement: the Geodesy Calculator, the Geodesy Graphic Tool, and range rings. Let's take a look at each one. The Geodesy Calculator tool performs two different functions. If you give it a starting location and a bearing and distance, it will calculate endpoint coordinates. Or, if you give it a starting point and an ending point, it will find the bearing and distance between them. You supply the point coordinates using the coordinate tool and the units of bearing and distance and the type of line you wish to calculate. The Geodesy Calculator will also draw a graphic line in the ArcMap display and label it with the bearing and distance between the starting point and the ending point. Because this tool creates a geodetically correct line, if you were to change the coordinate system of your map display, the line would update to maintain its accuracy in the new coordinate system. The next tool is the Geodesy Graphic Tool, and very much like the Geodesy Calculator, it will find the bearing and distance between a start point and an end point. But it's an interactive tool that draws the line on your map display. I demonstrated this tool earlier in the overview of Military Analyst. The last of the Geodesy tools is the Range Rings tool. Range Rings builds a set of concentric geoellipses from a center point. You specify the center point with the coordinate tool and give it a number of rings, an interval between them, and a number of radial lines to draw. It's important to note that while the rings may seem distorted in one coordinate system or another, each point along the ring is the exact same distance from the center point. Remember that it's the map's coordinate system that's distorting the shape of the ring. Okay, let's stop here and take a look at some of the tools I've been talking about for the past few minutes. I'll switch back to my ArcMap display, and we'll go to a different data frame of Europe and Northern Africa. The first tool we'll take a look at is the coordinate tool, and as I mentioned, it's a dockable window, and it does basic coordinate conversion. Say, for example, I have a set of latitude, longitude values. I'll type them into the box, and we'll click on Convert. And notice that the other values, the degrees, minutes, seconds, UTM, and MGRS coordinates are filled in. I can also use the tool to center in on a specific location and draw a graphic point. I'll go ahead and dock the tool, set my options to draw the graphic and center on the display. And this time I'll type in a set of MGRS coordinates. Notice that as I type in the coordinates, the values are in red, showing me that up to this point it is an invalid coordinate. But as I start adding more digits, the values turn black, showing me that I now have a valid coordinate. I'll click Convert. And we'll notice the map display shifts a little bit, and I now have a purple coordinate symbol showing me where that location is. Next, let's take a look at the Geodesy Calculator. As we mentioned, this tool will draw or calculate the distance between a starting point and an ending point. If I give it the starting point using the coordinate tool and an ending point, let's actually use the coordinate tool to enter the ending point coordinates. Move the menu out of the way. I'll use another set of MGRS coordinates. I'll click Convert. And notice it adds those values into the ending point location on the Geodesy Calculator menu. Next, I'll specify my units and distance that I'd like to find out. We'll use US survey feet and gradients. I'll select the type of line I'd like to create. We'll use a geodesic line. And we'll tell it to display our graphics and label them. And here I've actually calculated a distance between these locations of, well, about 1.4 million US survey feet at about 105 gradients between those two locations. We'll clear that calculation out and we'll take a look at how it calculates endpoint coordinates. In this case, I need to specify a starting location, and I'll specify a distance and a direction. So let's use about 2,000 kilometers at 90 degrees. And this time we'll calculate a run line. And in this case, we've calculated our endpoint coordinates and a corresponding graphic on the map display. The Geodesy graphic tool is very similar to Geodesy Calculator in that it is going to draw a geodetically correct line. But as I mentioned, it's an interactive tool, so I can basically just drag and drop my line across the screen between my two locations. I notice here that as I've drawn this line, it's calculated a distance and direction of 1,887 kilometers at 71.8 degrees. I can change those units in the Military Analyst Options dialog. Instead, I want to calculate in, say, radians and miles. I'll redraw another line and notice that it will update with those values. 1,175 miles at 1.1 radians. I'll go ahead and clear those graphics from the screen. And we'll take a look at range rings. Range rings is going to build that set of concentric geoellipses from a center point. The center point is specified with our coordinate tool. So I'll select a location. Notice it snaps to that point feature class as I cursor over it. Next, I need to set a number of rings. Let's draw 10 rings at about 100 kilometers in between each. And we'll tell it to draw 8 radial lines extending from the center point outwards. We have options also to label the rings and label the radials, but I'll leave those alone for the moment. We'll click Apply. And we have the graphic drawn on the screen. It's important to note here that each of the points along these rings are the exact same distance from the center point, even though the shape of it is not an exact circle. And that will be true no matter what coordinate system I change to in my map display. Right now, I'm in Geographic WGS84. Let's change my coordinate system to a projected coordinate system. let's actually go to world and we'll use a Robinson projection. There it is. And we'll say OK. Now watch, we notice that the shape of the rings has changed, but they generally follow the exact same path that they went through before. That's the importance of using geodetic measurement, is that no matter what your coordinate system is, the updates will not affect the distance and directions used in these geodesy tools. So in this first section, we talked about coordinate conversion with the coordinate tool and convert coordinates in file and how they convert between MGRS, UTM, DMS, and decimal degrees. Then we discussed the importance of geodetic measurement and looked at the three tools in Military Analyst that maintain their geodetic accuracy: the Geodesy Calculator, the Geodesy Graphic Tool, and range rings. We followed that up with a demonstration of manual conversion with the coordinate tool and how it was used to enter points into the Geodesy Calculator. The Geodesy Calculator draws those geodetically correct lines on the map display and calculates the direction and distance, or endpoint coordinates, depending upon the type of analysis you're doing. The Geodesy Graphic Tool will interactively draw those graphics on the screen as well. And we followed up with range rings, which draws the set of geoconcentric rings about a center point and maintains their accuracy no matter what the coordinate system is. So let's stop for a few moments here and take a few questions that have been coming in to us. Lorraine?
Thanks, Matt. Our first question comes from Yvonne in Pittsburgh. She asks, can Military Analyst be used in ArcGIS 9.1 or ArcView? Well, the answer is yes to both of those. The Military Analyst is not limited to the license level, so you can use it in ArcView, ArcEditor, and ArcInfo. Military Analyst can be used in ArcGIS 9.1, but Military Analyst 9.1 has to be used. Military Analyst 9.2 cannot be used in ArcGIS 9.1. We have a couple questions about the Convert Coordinates in File tool. Jordi from Barcelona asks, can I run a batch conversion from degrees, minutes, seconds to decimal degrees? He has about 300 values. And the answer to that question is yes, you can. You can use that Convert Coordinates in File batch conversion tool to convert coordinates from any of the formats, decimal degrees, degrees, minutes, seconds, UTM, and MGRS, to any of those other formats. Either append those to your table or write that to a new file. One thing I have to mention is you can use when you're using the degrees, minutes, seconds as an input, you can use either one field or two fields.
Okay, we've got a question from Tracy from Ashland. Do I need to convert my data coordinate system to DMS before I can use MA analysis tools? And the answer to that is no. You do not need to convert your data before you use any of these tools. The conversion is simply there in case you receive information or you receive coordinates in DMS or Military Grid Reference System or UTM coordinate values, and you want to convert them to decimal degrees. So it's just there for conversion. It is not a requirement to use those for analysis.
Okay, we have another question from Enrico in Sterling. He asks, is it also available for ArcGIS Server? So is Military Analyst available for ArcGIS Server? At 9.2, Military Analyst is not supported on server, but at 9.3, it will be.
Okay, we have another question from Gavin. Gavin wants to know, what is DTED? Good question, Gavin. DTED stands for Digital Terrain Elevation Datasets, and just as its name implies, it's elevation data, and it is supplied to customers through NGA, through the National Geospatial Intelligence Agency. You can go to their website and download a sample of that type of data. We use it as elevation data for different types of surface analysis. We'll see some of this in our last section of today's seminar when we go through our terrain analysis tools.
Okay, we have time for one more question. Mary from Arlington asks, in the batch conversion, can you have multiple types of coordinates to convert to decimal degrees, or do they all have to be the same? When you're converting coordinates, your input format does have to be in one of the supported formats. You can't have various formats in the field you're using as your input. You can run the tool multiple times and convert all your other formats to decimal degrees if that's what you would like to convert it to. Okay, we'll move on to the next section.
Okay, our next section in today's seminar is data management, specifically using NGA data sets in ArcGIS through the use of military analyst catalogs. Military analyst catalogs act as a collection point for DTED, RPF, or VPF data files. For example, a single VPF catalog will store references to all of the VPF data products on your system. While a small collection of VMAP1 data would look like the file structure on the right, it can be put into a single VPF catalog. The different military analyst catalogs can also store data for different scales or different resolutions. For example, DTED level 0, DTED level 1, and DTED level 2 all have different cell resolutions, but can be stored in the same catalog. RPF and VPF have the added ability to switch to the appropriate product type at different map scales. This scalable display allows you to see different RPF or VPF data sets as you zoom in or zoom out of your map display. The tool used to load military analyst catalogs can also reduce the work and time required to get your data up and running. The loader takes a starting folder and will recursively search the underlying directory structure, loading the required data tiles as it goes. This means you won't have to search through the folder structures and add the tiles yourself. We'll talk more about creating the catalogs during the demonstration, but let's go through the display properties for each of the catalog types. The DTED catalog displayed in ArcMap will choose the first DTED type it finds in the catalog. If you loaded DTED level 0 first, then your DTED 0 will be the default type that it will display. You can change to other DTED types found in your catalog through the display properties. Initially, you'll also notice the wireframe outlining each DTED tile. Essentially, it outlines the boundary of the individual DTEDs that make up the catalog, and the color denotes the DTED type. Each DTED type will be drawn with a different color. The DTED catalogs can also use a uniform renderer to render the tiles within the display extent. This means that all of the adjacent tiles within the display are drawn with the same renderer. The effect is a smooth transition between adjacent tiles. And if we turn off the catalog wireframes, the catalog would look as if it were one single raster data set. Those of you who use regular raster catalogs will notice the difference between the DTED catalog display and the raster catalog display. In a regular raster catalog, each individual tile is drawn with its own renderer and makes the boundaries between adjacent tiles look much more obvious. With RPF catalogs, you will also see a wireframe outlining each RPF tile in the catalog. And just like DTEDs, the color of each outline denotes the different RPF products. A listing of the different colors and which RPF products they represent can be found in the Military Analyst section of the ArcGIS online help. RPF catalogs have two different options for displaying the different RPF products at different map scales. The best map set option will change the RPF product as you zoom in or zoom out through different map scales. So as your map scale changes, the RPF displayed in the map will change, literally choosing the best map set for that map scale. The lock map set option allows you to choose one RPF product to display at all scales. So if you choose to lock in your joint operation graphics, for example, it won't matter what scale you set your map to or how much you zoom in or zoom out, it will only display that RPF data set. Just like DTED and RPF, the first thing you'll notice with VPF is that there is a wireframe outlining the different VPF product tiles, and again, different colors denote different products. Also, like RPF, the VPF data in your catalog has the ability to scale with your map display. That is, different VPF products will turn on and off as you zoom in and zoom out through different map scales. The benefit here is that you aren't displaying all of your VPF for your catalog at the same time, which can clutter your view and take a long time to draw every single feature. I should mention that using scaling with VPF may seem a little bit different than using it with RPF. If you have your VPF features selected to draw, but you aren't at the correct map scale for them to turn on, your display is going to be blank. This is simply a reminder that you have to either zoom in or zoom out or pan to the correct location to see your VPF data sets. Another option you have for displaying VPF data is the ability to draw VPF with the GeoSim renderer. The GeoSim renderer is the NGA standard symbology set for VPF data. By default, all VPF data will be drawn with GeoSim. This can be turned off in favor of ArcMap's standard symbology sets in the display options. So we'll stop here again and do a data management demonstration. I'm going to cover creating and loading a Military Analyst catalog, and then we'll show you the display options for all three catalog types, DTED, RPF, and VPF. So we'll switch back to my ArcMap session and go to a different data frame. And I'm going to turn on Arc Toolbox and go to my Military Analyst Tools. Under Data Management, we'll see 4 tools for creating and loading DTED data, NGA data. There's 3 tools for creating. 1 tool to create your DTED catalogs, 1 tool for creating your RPF catalogs, and a 3rd tool for creating your VPF catalogs. These tools simply create the schema in your Geo database. They do not load the data. That's done by the Load MA Catalog tool. Let's actually go through the process of creating a brand new DTED catalog. First thing I need to do is open my DTED tool and point to a target Geo database where I want to store my DTED catalog. Give that a moment to update the path, or maybe a few moments to update the path. And next we'll specify a catalog name. We're going to go ahead and run the tool. And as I mentioned, this is simply going to create the schema, the structure for this catalog in that geodatabase that I specified. You can specify either a file geodatabase, a personal geodatabase, or an ArcSDE connection. So now that I've created the schema for my catalog, I'm next going to load my tiles into it using the Load MA Catalog tool. This tool, I'm going to point to that target geodatabase. Here's my new DTED catalog. And then I'll specify a parent folder that is storing all of my DTED data. Oops, let's select the right folder. There we go. And what this tool is going to do is it's going to recursively search through that directory structure. As it finds DTED tiles, it's going to load them into the catalog. You do not have to specify any subfolders or subfiles. It will find them for you. So at this point, the tool automatically adds the catalog to the display extent, but it does it through the regular Add Data button. We're going to remove it and add it as a Military Analyst DTED layer. So we use the Add MA Layer button, and we find our new DTED catalog, and we'll add it to the map display. At this point, I'll turn off our toolbox so we can see a little bit more of our catalog. The very first thing we'll notice is the outline. The DTEDs of the tile boundaries are colored in red. This pretty much means I have DTED level 1 data. The colors for the different DTED tiles are also listed in the ArcGIS online help under the Military Analyst section. You can also see the smooth boundary, the smooth transition between tile boundaries of my DTED tiles. We go to the display properties, and on the display tab, we can see I have a list of the available DTEDs that were found during the load process. It found DTED level 1 and DTED level 2. Here's where I can switch between showing level 1 or level 2 data. I'm going to go ahead and stick with DTED level 1 for this demonstration. Just to the right of that, I have options for displaying my wireframe. I can turn the wireframe off completely or display it only for the products that are visible or all of the products within the entire catalog. This is also where I can specify to use my uniform renderer. Remember that uniform renderer is going to do that smooth display across those tile boundaries. Let's turn it off for a moment, and I'll go back to my map display and show you what it looks like without the uniform renderer. In this case, each tile is drawn with its own separate renderer using its own separate set of statistics. So you can see the boundaries or the differences between the tile boundaries quite easily. The colors don't transition nicely either. By going back to my map display and turning on the uniform renderer, it's actually going to look at the statistics for the entire catalog and come up with one single renderer to display all of those tiles. Let's actually go back and turn off the wireframe completely. Without the wireframe, it almost looks as if this catalog is one single raster data set, which it really isn't. It's this catalog of data sets. Okay, next let's take a look at our RPF catalogs. I'm going to go ahead and turn on my RPF catalog, and just like DTEDs, the first thing I can see is wireframes outlining each of my RPF tiles. For the different types of RPF data, the different RPF products, there are different outlines and different colors. You can see some of those along the edge of my image here. If we go to the properties for our catalog, we have to see a list of the available products that were found in this catalog. They're turned off because of my current display option set for use best map set. I'll explain that in a moment. We also have wireframe display options, just like the DTED, to not display it at all, display it for everything in the catalog, or only those products that are selected. And below that, we have our options for displaying our different RPF product types. By using the best map set option, the system is going to choose which RPF product is best to display at my given map scale. So right now, at this scale, I'm displaying, let's see, it looks like joint operation graphics. As I start zooming in, at a specific scale, I'm going to switch to a different RPF product found in my catalog. Let's see right here at this scale. This looks like some kind of TLM data. I zoom in a little bit closer, and eventually I'll get to my aerial photographs that are also part of this catalog. As I zoom back out again, the same process. It finds the correct map, the best RPF product to display at my map scale. If I go to my properties again and I switch to my lock map set, I'll choose one product to display at all scales. So it's literally going to lock in my joint operation graphics. And no matter how far I zoom in, that's the only RPF product I'm going to be able to see. Again, with zooming out, it's locked into that one RPF type. I'm going to zoom back out to my full extent, and we'll take a look at our VPF catalogs. Just like RPF and DTED, we have outlines for each of the VPF tiles in this catalog. And we go to our display properties, and we can see under the VPF product selection that in this catalog I only have VMAP level 1 data. On the right-hand side, I've got a listing of the different feature types that I have for VMAP level 1. And let's say I want to display my industry, transportation, and utility types. Again, wireframe display options, just like DTED and RPF. Under my VPF layer display options, I'll turn on my data files. And this is where I can use the GeoSim symbology. It's basically a checkbox, and it's on by default. Remember, the GeoSim is the NGA standard symbology set for VPF data. I can also turn on my scale dependency. Once again, it's on by default. And just like RPF, it's going to display different VPF products at different map scales. So right now, as I switch back to my map display, we can see that my VMAP is not available. It's not turned on. That's just a reminder that I have to zoom in to a map scale at which I'm going to see it. So I'm zooming into a close enough region. I'm going to turn off the RPF catalog so I can see the VPF a little bit closer. And I'm going to zoom in one more time. And there we go. I am now at the correct map scale to display my VMAP level 1 data. And we can see a sample of this VMAP data drawn with the GeoSim renderer. As if I were to zoom back out again, it would, of course, disappear because I'm at the incorrect map scale. Oops. And there we go. We've zoomed out. Okay. In this last section, we just talked about the military analyst catalog structures, how we created the catalog through the create DTED, create RPF, and create VPF catalogs. And we talked about loading them, and I guess let's actually stop for a few moments and take some questions that have been coming in. Lorraine?
Thanks, Matt. Jim in Lansing has a question that pertains to the first segment that Matt covered, the Geodesy tools. Are the range rings or other graphics exportable as data layers? When you run the range rings or Geodesy Calculator, Geodesy graphic tools, what you get in your map display is just a graphic. So you cannot save those as feature classes or layers. There's a script. I'm going to point you to Eden from the support site, the ESRI Developer Network. There's a script that is available that may help you do that. So take a look on that site. We have another question from Ivan in Las Cruces. He asks, can I customize ArcGIS Military Analyst? The answer to your question, Ivan, is yes, you can. The Military Analyst SDK contains an API, samples and snippets, and documentation to help you get started in developing your applications.
Okay, we also have a question from Dustin, and Dustin would like to know how the directions of the radials and range rings determined. Basically, Dustin, what happens is you have a 360-degree circle, and the number of radials that you specify to draw divides that number of 360 by that number to figure out the interval in between each one. So if I were to say to draw 4 radials, it would basically split 360-degree into 90-degree segments and draw them with that interval. Same thing if I specified 8 radials to draw, it would split it into 45-degree segments and draw them at that interval.
Right. Owen in St. Paul asks, I'm an Eden subscriber. Do I have to purchase the ESRI Defense Solutions? Owen, the Defense Solutions products, both Military Analyst and MOLE, are free for you to download off of the ESRI product site. So you do not have to purchase anything. Melissa in San Diego asks, I have old oil stock files from 1999. Can I bring them into ArcGIS? The answer to your question is yes, you can. You may have noticed that Matt did a demonstration, and in the Military Analyst toolbox, we have 3 tool sets. He used the data management tool sets, the geoprocessing tools. We have another tool set, the utilities tool set, which includes the oil stock overlay tool. So this will convert your oil stock overlay files to feature classes, and then you can view and analyze them in ArcGIS. Okay, Matt?
Okay. In our final section of today's seminar, we'll talk about military analysts' terrain analysis capabilities. Military analysts' terrain analysis tools perform many basic common terrain analysis tasks, many of which can also be done using Spatial Analyst or 3D Analyst. But the advantages Military Analyst has over these other extensions is that the workflows to do these functions has been simplified quite a bit. For example, you're able to work across tile boundaries in Military Analyst catalogs. If we wanted to do a viewshed in Spatial Analyst, we would first have to mosaic sections of our DTED catalogs together into a single raster dataset, because the viewshed tool only accepts a single raster dataset as the surface input. Next, you'd have to create a new point feature class to represent your observer points, and after all that is done, then you can run the viewshed. But through Military Analyst's Radial Line of Sight tool, we compress that process into one single tool, which I'll talk about in more detail in a moment or two. All of the terrain analysis tools are available on the Military Analyst toolbar menu or on the Military Analyst tool palette in ArcMap. Many of the tools also feature the coordinate tool as an input device to specify the location of an observer or a target point. Before I actually discuss the terrain analysis tools, I'd like to make a note about licensing. Because many of these tools are built from existing tools in Spatial Analyst and 3D Analyst, they will require licenses from one or the other. The table you see on your screen is a listing of the tools and which licenses they require. This table is also available in the Getting Started guide that comes with Military Analyst. A few examples would be the highest point tool and lowest point tool, which require Spatial Analyst to run. The linear line of sight tool requires 3D Analyst. And the radial line of sight tool and both Hillshade Command and Hillshade tool will work with either Spatial Analyst or 3D Analyst. Please note that the licensing requirements only apply to the terrain analysis tools. All of the other functionality, the coordinate tool, the convert coordinates in file, and the data management functionality do not have any license restrictions. This table also shows all of the tools that will accept catalogs, DTED catalogs or RPF catalogs as input, and that also most will accept individual raster data sets as well. Okay, let's actually take a look at the terrain analysis tools that come with Military Analyst, starting with Mosaic and Extract. These tools will take an RPF or DTED catalog and combine the individual tiles into a single raster data set. You can create an ESRI grid, a TIFF file, ERDAS Imagine, or a geodatabase raster from the catalog specified in the Layers dropdown on the Military Analyst toolbar. The Mosaic command, which is found in the menu dropdown, will extract the entire catalog to a dataset, or will take a selected set of tiles, or it will do just those tiles that fall within the visible extent of your map display. The Extract tool, on the other hand, from the Military Analyst tool palette, will combine data from a selected region of your map display. You will use the tool to draw a window around the region that you wish to combine. The Hillshade command and the Hillshade tool will create a shaded relief version of a DTED catalog or a surface raster dataset. It features an automatic Z-factor conversion that will scale elevation meters to the same number of units as your geographic units. The output from the command and the tool can be saved to an ESRI grid for later use, but the default is a temporary raster dataset that will remain as long as your ArcMap session is open. The differences between the command and the tool is that the Hillshade command will hillshade your entire catalog, a selected group of tiles, or will hillshade all of the tiles in the visible extent. The Hillshade tool, on the other hand, will shade a selected region that you draw a box around. The highest point and lowest point tools are pretty self-explanatory, and within a selected region, these tools will find either the highest point or the lowest point. This is useful in locating a potential observer location or a place to remain unobserved. The resulting layer that is added to the map display will tell you the elevation of the point. The highest point results will be drawn with a red point symbol, and the lowest point results will be drawn with a black point symbol. The Radial Line of Sight tool does a visibility analysis from an observer location and answers the question, what can I see if I were standing here? It's similar to the Spatial Analyst's Viewshed tool, but like the rest of the terrain analysis tools, it will work across your DTED tile boundaries. The results are a set of polygons showing areas that are both visible and invisible to the observer. The tool parameters can be modified to further enhance your analysis results. They will allow you to specify a near or far distance from the observer, a horizontal field of view, and a vertical field of view, as well as observer offsets from the surface and a terrain offset. The radial line of sight will also allow you to input multiple observer locations and will code the visible polygons by the number of observers that can see a given location. So if you happen to have a polygon that has a value of 3, that means 3 of the observers can see that polygon. The last of our terrain analysis tools is the linear line of sight tool, and this tool does a point-to-point visibility and will tell you if you're standing in one location, can you see another location? We'll use the coordinate tool to specify the observer and target locations, and you can set an offset above the surface for each of them. After running the tool, the ArcMap status bar will tell you if the target location is visible or not. The tool will also show a surface profile of the elevation changes along that line of sight. You will also be able to see the line between the observer and target change to tell you if the surface is visible. The line will be colored green for visible areas or invisible with red. Okay, we've talked about a few tools here. Let's actually see some of them in action. So I'm going back to my ArcMap session, and I'll switch to a different data frame where I'm showing a DTED catalog, once again, of the Big Island in Hawaii. And we'll start off by looking at the mosaic command. Now, as we saw in these slides, the mosaic command is going to combine tiles or sections of tiles of your DTED catalog or RPF catalog into a single data set. So in this case, I'm going to use my Hawaii DTED catalog, and I'm going to create an ERDAS Imagine image. And in this case, I want to combine all of the tiles in the visible extent. So I can see that within this view, I have 4 tiles visible. I have the main one here, another one just to the north, a small section of 2 different tiles off to the west. Military Analyst is going to look through the catalog and find all of those tiles that fall within the display extent and combine them into a single data set. If I zoom out a little further, I can see that the combined area roughly corresponds to my display extents. Go ahead and turn that off. And next we'll take a look at the Hillshade tool on the tool palette. The Hillshade tool is going to do a shaded relief of a DTED catalog within a selected region. So I use the tool to select my region. I can specify my azimuth and altitude of my light source for the shading. I also see my z-factor that he listed here. The z-factor, again, is going to scale my elevation meters into geographic units for this analysis. I can also specify an output raster and save it to an ESRI grid, but I'm going to stick with the temporary output. As I run the tool, and take a look at the results, we can see that we have a shaded view of this DTED. So next, let's take a look at our highest and lowest point tools. Highest point, just like its name implies, is going to find the highest point within a region. So I'll go ahead and run the tool within a certain area. My result is returned as a red dot on my map display. And the table of contents tells me that this point is at 4,156 meters. The lowest point is going to do very similar. It's going to find the lowest point within my selected region. And down here at the lower left of my area of interest, I have a black point representing 1,355 meters. So between the highest point and lowest point, maybe I want to know if one point can see the other. To do that, I will use the Linear Line of Sight tool, and I'm going to specify the highest point as, let's say, my starting point, and the lowest point as my ending point. I also have the option to set an offset above the surface. So say at my starting point, I'm standing on top of a 5-meter tower. And say my target point is also on a 5-meter tower. I'll run that tool, and it will tell me the first result, and the most important is going to tell me if the target is visible. So in the lower left-hand corner on the ArcMap status bar, it tells me that this target is not visible. The resulting surface profile kind of correlates that and tells me that, okay, if I'm standing up here at my highest point as my observer, I'm not going to see my lowest point because I happen to be on the other ridge of this volcano. So all of the features in between are pretty much going to obstruct my view. I'll switch back and take a look at my ArcMap display. The line is colored to show me which areas are visible or not. Unfortunately, at Military Analyst 9.2, there's a defect that actually switches the colors. False is drawn in green, and it should be red. That's easy enough to change with the symbology. I'll go ahead and change my true, which should be green, and I'll get the correct results. So along this line, we can see that this section of my line of sight is visible to the observer, and the rest of it is not. So say I wanted to know in the highest point or the lowest point, what can I see if I was standing at either location? Let's use the Radial Line of Sight tool to tell us that. So once again, I'm going to specify my observer location, which will use the highest point. Notice the graphic denoting my area of analysis. Here I'll modify this, and remember I'm standing on top of my 5-meter tower. That's the center offset, pretty much my offset above the surface. I can also add a terrain offset, which can account for an average tree height around the surface. I can also modify the distance range from the observer. If I'm only interested in everything between 5 and 10 kilometers, I'll enter it here, and the graphic will update to show that. I'm going to use everything between 0 and, let's say, 20 kilometers. I can also specify an azimuth range. This is going to be my horizontal field of view. If I only want to consider everything from, let's say 0 to 180 degrees, I'll enter it here. And as I move my menu out of the way, you can see there's a half circle pointing in that direction. That means the analysis is only going to be done within this half circle. I'm going to go back to the 0 to 360, though, just because I'd like to know what I can see all the way around me. Here's where I can specify my elevation range. This is an angle below and above that I'd like to consider if I only wanted to constrain it to a certain small area. An observer elevation, we can enter that here as in the menu. An observer elevation is an absolute elevation above 0, above sea level. So if I went out with a GPS and I collected an absolute elevation, I would enter it here. In this case, I've considered my highest point, but I also want to consider my lowest point and see what the lowest point can see. So I can use multiple observers by adding them to my radial line of sight list. I've added my first analysis. I'm going to select my lowest point next. And I'll use the same parameters again and just add that second point to my list. I'll apply the tool. This is going to run it. And in the background, if we were to cross multiple DTED tiles in our DTED catalog, it would actually stitch them together and combine them into one single data set behind the scenes. So this is where that simplification happens from the Spatial Analyst tools. So Military Analyst is doing that work behind the scenes for you. The result that we see on the screen is going to show us what's visible from those two locations. I'm going to change my display to color them. I'm going to take out the values of 0 because those are the invisible areas. And let's change the color to something else for the visible areas. Let's make them purple. Make them stand out a little bit more. Okay, back in the display, we can see that between these two locations, they're only visible for certain sections. So this, our lowest point can only see these areas within the purple. And our top observer point can see very little. I'm obviously in a very small bad spot here. So that pretty much covers the basics of our terrain analysis tools. We looked at the mosaic and extract tools and how they will take a DTED or RPF and pull them out to a single raster data set. We talked about the hillshade tool and the hillshade command and how they will hillshade your DTED surface or a raster data set. And then we looked at the highest point and lowest point tools for finding the highest or lowest points within a given region. And then we looked at the linear line of sight tool, which finds point-to-point visibility, and a radial line of sight, which does area visibility, basically view shed from an observer location. So we're going to stop for a few more minutes and take a few more questions for this section. Lorraine?
Thanks, Matt. Okay, we have time for a few questions, and we have one from Ciro in Springfield. Will military analysts take 6-digit MGRS coordinates and convert them properly? At 9.2, we support the 10-digit MGRS coordinates. And there, in the online help, you can take a look at all of the supported formats and what formats are supported for those coordinates, such as decimal degrees, degrees, minutes, seconds, MGRS, and UTM. So take a look in the online help if you have any other questions pertaining to what's supported and what is not. We have another question from Dean in Hartford. He asks, will the line of sight tools snap to existing points? And the answer to your question is yes, they will. If you have a point feature class and you want to run a line of sight tool, the linear line of sight between 2 points, Matt used the coordinate tool to place his observer points. That coordinate tool snaps to existing points.
We also have a question from Julie in St. Petersburg. Are DTEDs and DEMs basically the same? Can you do anything that MA can do to a DTED to a DEM? While DTEDs and DEMs are both elevation data sets, their underlying file structure is different. DTEDs was created, I believe, by the predecessor of the NGA, the National Geospatial Intelligence Agency, and DEMs, I think, were defined by the USGS. So the structures are the same. We can't use the loaders to create a catalog from DEM data files, but DEMs, once you import them into ArcGIS, can be used in many of these terrain analysis tools like Radial Line of Sight or Linear Line of Sight. So the tools will work the same.
Okay, we have time for a couple more questions. Angie and Orman asks, does military analyst support NGA DNC data? The answer to your question is yes, it does support digital nautical charts. Another question.
Okay, we've got a question from Bruce in Asheville. Can MA catalogs be stored in an RDBMS such as Oracle? If so, is MA the only extension that can access the catalog once it's created? Military analyst catalogs can be stored in an RDBMS through ArcSDE. ArcSDE to military analyst is basically just another type of geodatabase like file geodatabase or personal geodatabase. So you can store military analyst catalogs through SDE and Oracle. And as far as military analyst, the only extension that can access the catalogs once it's created, DTED catalogs and RPF catalogs will be seen as a regular raster catalog. So you're going to lose the ability to do the scaling and the outlining and some of the other functions that are specific to military analysts, but they pretty much are visible. BPF data sets are going to be seen as a polygon feature class. So once again, you kind of lose that ability that military analyst adds to ArcMap and ArcGIS Desktop.
Okay, that's about all the time we have for today. We're going to wrap it up. We thank you for participating and sending your questions in.
Okay, before we go, I'd like to point you to a few resources. First is the ArcGIS Defense Solutions download site. This is where you can download and install Military Analyst 9.2, and you can also download and install Military Overlay Editor, or MOL, Military Analyst's companion product. The second resource is the online version of the ArcGIS Desktop Help for 9.2. This is where you'll find more comprehensive coverage of all of the military analyst topics we've discussed today and some of the things that we did not get to cover. Your comments help us improve these seminars, so please take a moment to complete the survey. Just click on the Give Us Feedback link and take that survey. That information is very important to us. We hope you've enjoyed today's seminar, and on behalf of ESRI, I'd like to thank you all for attending.